Let's say the question was find the limit. So this is chapter 2. We write limit, L-I-M, the limit of 3x minus 2 as x approaches, let me pick a 2 here. For now, what we're going to do, I'm going to show you, there's a shortcut to that, but for now, we're going to make a table of values. Here's x, and there's the limit of that. Let's find the value of 3x minus 2. It says as x approaches 2. Let's pick some numbers close to 2. What is close to 2? Is 1.8 close to 2? Let's plug in 1.8 for x. And what are you going to have? 3 times 1.8. 5.4 minus 2. 3.4. Let's try 1.9. That's closer to 2 than 1.8. That's 3.7. You can use your calculator to plug it in. Let's try the 1.99. Getting closer now. That's 3.97. Let's try the 1.999. 3.997. What do you notice about that number? Where is it going to? 4. Okay. Looks like that number as x approaches the 2, as it gets close to the 2. From which side, by the way? When you look at the 1.8, 1.9, 1.99 in comparison to the 2. This is the 2 here. This is the 1.8, right? I'm just exaggerating with the picture. This is the 1.9. This is the 1.99. So as you approach the 2 from which side? That's the left side. We use the minus sign to indicate the left side. As x approaches the 2 from this side, that's the left side. The function, the limit of 3x minus 2 as x approaches 2 from the left side, that number happens to be approaching what? The answer? 4. That answer was going toward the 4. You can see it. It's getting closer and closer to 4. Well, let's look at it from the right side. That means you are more than 2. How about a 2.1? Let's begin even with 2.2, farther away. At 2.2, what is 3x minus 2 going to be? When it's 2.2, is that a 4.6? Let me try 2.1. Is that 4.3? Let me try 2.01. Is that a 4.03? And let me try one more, 2.001. 4.003. What do you notice about that number? It's going where? Also toward the 4. So the limit of 3x minus 2 as x approaches the 2 from the right side, that's also equals to 4. Making a table is not the best way of doing it. That takes a long time. That's usually the last resort. But I want you to see what's going on. You're getting closer and closer to the 2 from this end, and you find the y values approaching 4. Now you're getting closer to 2 from that end. That's the right side. And you're noticing here the y values approaching 2. Once the left and the side equal the same number, if the limit of 3x minus 2 as x approaches the 2 from the left side happens to equal the limit 3x minus 2 as x approaches the 2 from the plus side, then we say what? The limit as x approaches 2, we don't say left or right now, that's equal to 4. So as you approach the 2, the answer is 4.
Professor, does that mean then if we have two different answers
Then there's no limit, correct.
no limit?
No, for this would be no limit. If this was a 2 and this was a 3, well then we'll say the limit does not exist. We have a limit from the left side and we get from the right side, but as x approaches 2 will be no limit. Does not exist. And we'll have some of them, you'll see. I'll give you some in a few minutes where the limit does not exist. We have a limit from the left side, we have one from the right side, but not at that number. By the way, I said this is probably the worst thing to do is making that table. It's the long way of doing it. Is there a shortcut to get to that answer? And the answer is yes. The shortcut is really direct substitution. Plug in that number. If you end up with an answer, then you have a limit. So direct substitution says, well, you know what? If you want to find the limit as x approaches 2 of 3x minus 2, just replace x with 2. What are you going to have? 3 times 2 minus the 2, what do you have? And that's your answer. But not every problem you'll be able to do direct substitution into it. And if we can, we're going to think of something else. Maybe the table. Again, the table is my last option. Let me try another example. Good. Am I going too fast? Oh, let me leave these so I can take a snapshot of them later before I forget. Let me try this, the limit. I don't know, 3x squared minus 2x plus 1. Somebody pick a number, reasonable number, as x approaches 8. Okay. Again, we can do a table and look at the left side, look at the right side. You'll be wasting about 5 minutes of your life. Or we can try what? Direct substitution. Let's try direct substitution. Direct substitution says what? It's going to equal 3 times 8 squared minus 2 times 8, 2 times 8 plus the 1. 8 squared is what? 64. 64 times 3, 12, 8, 192. Minus 28 plus 1. 1, what is it? 16. Oh, 16, thank you. 2 times 8, 16, not 28, yeah, I guess. Well, if you just erase the brackets. I have a calculator, why not use it? Try to exercise my brain. I got 177, is that what you got? So that's your answer. What is the limit of 2x, 3x squared minus 2x plus 1 as x approaches 8? It's 177. That's the y value. The y value, if you were looking at it as you approach the 8, is going to be 177. If you don't believe me, I said, let's pick a number just to test it, see if it really works. Let's pick a number before the 8 from the left side. Let's use what's from the left side. You're not at 8 yet, so you were 7.999. That's close to 8, right? And if I plug into that equation, I should get roughly 177. And let me try it from the right side. The right side, the number is more than 8. How about 8.001? And let's see if these numbers actually approach the 177. 3 times 7.999 squared so 7.999 squared times 3 minus 2 times 7.999 plus the 1. I came up with 176.954. Is that close to 177? Yep. Let's look at it when you approach it from the other end. 3 times 8.001 squared minus 2 times 8.001 plus the 1. $177.04. 0.46. Notice we're not that far from these numbers, 177. We're talking about 0.05. And if you get closer, if you add another 9 here, another 0 here, you'll notice that number becomes 0.046. So you start to get closer and closer and closer to the 177. So usually that's my first step in finding the limit, is direct substitution. And if it doesn't work, I look for other ways of doing it.
When wouldn't it work?
Oh, I'm glad you asked that question. Let me give you one it doesn't work. The limit as x approaches 2, x squared minus 4 divided by x minus 2. Video 4. Okay. Direct substitution. What are you going to have? 4 minus 4 over what? 2 minus 2. 0 over 0. What is 0 over 0?
Undefined.
Undefined. When you get 0 on the bottom, it's always undefined, not a 1. I know 5 over 5 is 1. 7 over 7 is 1. 8 over 8 is 1. Not 0 over 0. Notice my calc that was said to me wrong. It's undefined. 0 divided by 0. I should get an error. Division by 0. It's a no-no. So direct substitution did not help me here. I need to look for other ways. I mean, I can do a table there, but trust me, I don't want to use the table. As I said, that's my last resort. So what can I do? Factor. I like that answer. Let's look at the top and factor. Is that x minus 2 times what? X plus 2. Does anything cancel? That becomes the limit as x approaches 2 of x plus 2. Now try direct substitution again. Direct substitution should give me what? 2 plus 2, which is 4. And that's my answer. So the limit of x approaches the 2 of x squared minus 4 over x minus 2, that's always equal to 4. Bless you. So that's one example where direct substitution didn't work. But I found an alternative way for that, and that is factor. Let me try another one. I'll wait. I'm in no rush. It's only 7 o'clock? Wow. It was like 8, 9 o'clock. I was about to check the score and see what the hockey game score is. You know?
Is this section 2-1?
This is 2-1, yes. I didn't look at it. I'm just going off the top of my head right now. So I'll look to make sure I don't leave anything out. Let me try another one where the limit does not exist. Let's take the limit of x over x minus 1 as x approaches 1. Again, what's the first step? Direct substitution. Try that first. Direct substitution, you'll have what? 1 over 0, which is undefined. Notice you got a 0 on the bottom. So you can't use direct substitution. Can we factor, simplify this, do something about it? No. You can try all day, all night, it's not going to work. If everything failed, what's the other option then? Table. So let's go to the table because I can't simplify this. Let's try x and x over x minus 1. Let me look at one side, 0.9. If I plug in 0.9, what are you going to have? Is that negative 9? I think it is. Let me try 0.99. That's a negative what? 99. Let's try the 0.999. Negative 999. Uh-oh. One more. Well, you notice that number is going toward what? Negative infinity. There's no point here. That's going toward negative infinity. That tells me there is no limit. But I'll leave it for now. So I can say the limit of x over x minus 1 as x approaches the 1 from the left side. That's approaching negative infinity. In our book, that'll be one section by itself. Infinite limits called. But you can see it's getting bigger and bigger and bigger, but with the minus value. Let's try the plus side. Yep, x minus 1 here. We'll try 1.1. Is that 11? We'll try 1.01. Is that 111? Or 101 is it? It might be 111. Let's see. 1.01. I think 101, I think. (101), yep. Let's try 1.001. Let's try 1.0001. What do you notice about that number? It's going toward what? Positive infinity. So the limit as x approaches the 1 from the plus side of x over x minus 1, that's approaching infinity. Since these numbers are not matching, they're not the same, there is no limit. So the limit as x approaches the 1, I'm not saying plus or minus here, DNE. DNE stands for what? Does not exist. does not exist. We have no answers to it.
We can write abbreviation. We can write D and E.
You can, well, they're gonna, if the software probably will tell you, it might be a button that says write N for does not exist, or it might say, give you option, and one of them it says does not exist. So they'll let us know which way they want to. I know in my math lab we used to write N for no solution. And I don't know what WebAdvisor uses, or Web Assistant, whatever was this, WebAssign? Yeah. We got so many programs, WebAdvisor, Web Assistant, WebAssign. So picture-wise here, first chapter. Actually, what I did here, so now this is section 2.3.
Oh, really?
2.2, finding the limit graphically.
Okay, so this is 2.3.
Yep. I just said I went off the top of my head there, but the book does 2.2, and that's finding the limit graphically. Just by looking at the picture.
So it's all things on 2.2.
So let me stop it.